Well, hello folks. Today I'm going to be working on this Macintosh 512k from 1984. Specifically, I'm going to show you two things. I'm going to be recapping the main logic board of this computer and recapping the keyboard. Yes, you heard me correctly. There are electrolytic capacitors inside the keyboard, so I'm going to recap this too. Number two, I'm going to repair this damaged caps lock key because when pressed, it does nothing right now. The content of this video today will also apply to the Macintosh 128k and the Macintosh 512k E standing for Enhanced. The video will not directly apply to the Macintosh Plus because the Macintosh Plus has more capacitors on its motherboard and also inside its keyboard, but the general techniques that you're going to see today will also apply to that computer as well. And down in the text description below, I will provide you with a complete Mauser capacitor list, a Mauser cart, to make it easy for you to buy all of the capacitors you need for both the motherboard and the keyboard for the 128k through the 512k E, and separately I'll give you a different cart for the Macintosh Plus. So let's get started. Here is my Macintosh 512k motherboard. We can know that because it says here on the sticker 512k. We can also know that by looking at the side here. There's a marking for 128k here and a checkbox over here for 512k. It actually has a check underneath this pass sticker here. And we can also tell by the markings on the RAM chips. There are these 256 numbers in these parts. There's 8 of them in 2 rows of them. This is a 512k motherboard. For your 128k motherboard, you'll very often see the Apple logo on the memory chips, and of course you'll see the appropriate marking and checkbox to indicate that. If you have the 128k ROMs in, then you have an enhanced machine, and these are the same ROMs that you would have in the Macintosh Plus. The type of ROMs you have doesn't change what we're going to show today in this video about recapping, so there's really nothing to worry about, but I just wish to point out that these ROMs you're looking at here are the 128k ROMs that are commonly found in the 512k E. For the purpose of recapping, we're going to focus our attention onto this connector side of the board here, and as you can see here, we only have these 3 axial type electrolytic capacitors that we have to deal with. This is C22. It is a 4.7 microfarad 35 volt axial, and these 2 capacitors, C20 and C5, are both 16 volt 33 microfarad. Now of course I'm well aware of the naysayers out there who say, hey, I use my 512 128k Macintosh Plus board and don't have any problems. I've never heard of people changing out these capacitors. They're axials. Why do you even need to change them? I don't think you need to change them. And there are people out there like that. I'm not criticizing them, but I disagree with their conclusions. And here's why. It doesn't matter if the capacitor is of the axial type or not. Axial meaning the legs come out both sides instead of straight up and down. All fluid-filled electrolytic capacitors have a finite life. They do not last forever. So why do some people say, oh, these last a long time, you never have to change them? You know, I'm sure that some of you have heard that. Why do they say that? Many people who use these boards don't have a lot of problems with them, at least problems pertaining to the motherboard other than RAM, and so many people have a false sense of confidence that the capacitors are just fine. But these capacitors, because as I said, they're axials, so the legs come out the sides instead of the bottom, gravity pulls a lot of the fluid to the base of the capacitor, and for a radial capacitor where the leg's going out the bottom, it's more pressure on that fluid to come out those leg holes. Whereas here on the sides, you don't have quite as much pressure, but that doesn't mean that these capacitors will last forever. I have seen axial capacitors leak. Believe me, they do leak. So you can be confident when you watch this video that what you're seeing here is something that you really do need to do after all of these years, replace the capacitors. And here are the replacement capacitors that I'm going to use that I purchased from Mouser. Again, there's a cart in the text description below where you can find these exact parts. The tapered edge of both types is the plus side. And I'm not just guessing, this is also from the data sheet. And it has a little circle also, just like pin 1 on an IC marks pin 1. This circle on these particular axial tantalums marks the plus side. So you want to be careful that you definitely connect the tapered edge to plus and then the opposite end to minus. And these are tantalum, which means you're never going to have to replace them. They are a little pricey, but if you're only going to do 1 or 2 boards, I think it's worth it. If you're going to do a lot of boards, perhaps using the regular electrolytic style that you're going to have to replace in 20 years would be much cheaper. But if you can do it, I would suggest the tantalums. The tantalums have the benefit over the electrolytic capacitors in terms of ESR. The ESR isn't a whole lot less. It is less, but it isn't a whole lot less, but it is more stable across the temperature range that these are allowed to operate. Aluminum electrolytic capacitors, on the other hand, have higher ESR at lower temperatures. So these are unaffected by that. We can see here this is the 4.7 microfarad rated at 50 volts. So it's plenty high voltage to where you're not going to get a voltage spike that's going to exceed that. And you know, solid tantalums, if you get a voltage spike above their rating, they can catch fire. But this is 50 volts. Now these are rated at 25 volts. They have a 35 volt. You can get them in a higher voltage in the same exact size physically, but they cost more. So 25 volts rating for a board that's going to have 5 volts and 12 volts going through it is more than adequate as a safety margin to where you're not going to get a voltage spike. I mean, if you do get a voltage spike above 25 volts, you're going to have a serious problem on your motherboard. So again, these are definitely over-spec'd so that you don't have to worry about spikes that are going to ignite these. And again, because they have a solid electrolyte, no fluid inside, you're never going to have to replace them. There are 2 different approaches that you can take to replacing these. One of which I've tried before is you just take your nippers and snip off the old capacitor, leaving the leads intact, and then solder your new capacitor on the existing leads. So if you don't have a lot of experience with soldering and you want to give that a try, you know, the pros out there will shake their nose at it, but it actually does work because the legs don't easily fall through these multi-layer boards. However, today I'm going to do it, I guess you could say, the best way, which is to fully desolder these. And normally I do not use flux. Even though flux is normally in the solder, inside the solder I use, sometimes it can be helpful to add additional flux, especially on situations like this where I have a multi-layer board. This is a fairly popular brand. It's the MG Chemicals part number 8341-10ML. It has some fairly decent reviews, and some say it can be difficult to get out of the pump if it's too cold, but it's not cold today. And actually, I have never used this particular brand before. Again, I normally don't use flux, but we're going to see how well it works to fully desolder these axials off the multi-layer board today. Here's the bottom of the board. C22 is, I put some flux on this pad here, and here is the other foot. I did not clip off the capacitor. It probably would be easier to do it, but I'm going to see if I can just pull him out and desolder him with my desoldering braid using this flux. Let's see how it goes. Well, we can see that there's still solder on the top side of the board on this capacitor. I might need to clip him off, but we're going to keep going. Apply a little bit of flux on both sides. It is coming out. And we don't want to yank on him. We don't want to damage any connections to the middle traces. So with the capacitor removed, I have some alcohol on this swab that I will use to clean up this flux. It has a fair amount of rosin in it, so it's pretty sticky, stays on the board. And get the bottom as well. By the way, whenever you're using flux, and even when you're soldering without extra flux like I am, it's a good idea to have a fan to kind of blow away the fumes. Not that you're going to keel over dead because of them, but this particular flux anyway did say don't even get it on your skin. It's toxic, and definitely don't get it in your eyes and that type of thing. So keeping a well-ventilated area when you're soldering is always a good idea. If you can keep a window open, that's even better. Okay, I've got my meter. We'll just do some continuity checks here. On the negative side, and this trace goes all the way through, so that's fine. And the square is a positive. Now, the positive, there's a variety of things it goes to on different parts of the board. But if I probing the floppy disconnector, I'm getting continuity on that. So this is telling me that we removed it successfully and that it's not broken. We take the plus, we see it goes through the thick trace to Q3 here. That's just fine. The negative side goes up here to CR2, and that's fine as well. So we didn't mess anything up. So I have my replacement capacitor with his legs bent appropriately. And again, the tapered edge, we want to definitely make sure it goes in the side that's plus. So just like so. So I have the feet bent out a little bit to the side here so it won't fall through. And we'll just apply our solder here. We see that there's solder that came through the board on this side as well. So both sides are perfectly soldered, and we just need to use some alcohol and a swab to clean off the excess flux. And of course, snip off the excess leads on the other side. So here's my DE5000 LCR meter, which is really the best handheld meter you can find that will measure resistance, capacitance, and inductance. This will allow us to measure the capacitance and the ESR. There are a variety of tools that come with it. This isn't really the best one, but I have it connected right now, so I'll just use that. We want to make sure that the negative side of the probe goes to the negative side, which is pointing over here. And then, of course, I have it all set up. RP means it's going to show the ESR here, and then the capacitance will show down here on the bigger number. So 4.8 microfarad, the capacitance is all right. The resistance ESR at room temperature is about 7.4 ohms. And here is the replacement tantalum for it. Again, we want to make sure plus is over here on the tapered side. And we see 4.6 microfarad, it's about 2.2 ohms, so lower ESR. And again, the other benefit, not only is it lower ESR, but this ESR is stable even down to 0 degrees and below, whereas the fluid-filled aluminum electrolytics do not have a stable ESR at lower temperatures. And just to let you know, this is measured at 120 hertz, and on this meter you can adjust the frequency. Right now it's 1 kilohertz. You can go up to 10 kilohertz and even beyond. Sometimes it won't let you measure ESR at 100 kilohertz, but in this case it does. And of course your capacitance changes based upon the frequency, but most of the time 120 hertz is about right. If you want to compare with the data sheet, you need to see what they're using, but many times they're using 120 hertz. We'll now desolder C20. Sometimes it's easier to desolder if we add a little bit of solder. Well, it's still not coming out, so I will try my pump here. Okay, so now I will try snipping off the body and see if that helps. This one is the hard one, so we'll try adding solder. I'm now going to try my desoldering station since everything else has failed. Well, that didn't work, so that was at 350 degrees Celsius. I'm going to apply some solder. I turned up the temperature a little bit, so we'll see how this goes. This guy does not want to come out. Well, I finally got it desoldered, and it was impossible for me to get all the solder out, so I had to get my little poker here and poke a hole. You want to be careful because you definitely don't want to drill it out, and you don't want to put something too thick so that it's going to break the connections in the middle of the board, and that's really the danger of trying to remove these. My goodness, it took me well over an hour just to get this cleaned out and a hole through it. So, wow. Here's the replacement capacitor, and I checked it so that I'm able to get the foot through both of the holes now, so that's not going to be a problem. But for you, for the other capacitor that we did for the first one, that might be okay to desolder fully, but for this one, I think I'm going to suggest to you for the two big capacitors that you might want to just cut off the old, leave the legs, and then solder on to the existing legs. But anyway, now that I have this done, I am going to take my continuity checker. See, when I put them together, it beeps. So this guy over here is a ground, and that's over here on this side of R23, so it's making good contact. And then the plus side is going to go to this pin here. That's giving me a good 0 ohms there too. So that is showing that I did not damage the traces in the middle of the board, which is really the danger here if you're going to fully remove the capacitor. So I'm going to solder in the replacement, And then for the last capacitor over here, I think I'm just going to clip off and show you what I mean by leaving the existing legs and soldering the new capacitor onto those. Okay, let's take a look at the ESR of the stock 33 microfarad capacitor with our DE 5000 meter. Of course, we see the marking. The right side is negative, so we want to make sure our probe is set up accordingly. All right, we see it's about 30 microfarads and 4.8 ohm ESR, neither of which are necessarily bad. If we look at, that's the angle, this is dissipation factor. And here's Q. Q is the quality. We see it's about, so the quality is about 9. And again, the ESR, which is, okay, now it's showing 4.7, just under 5 ohms. That is measured at 120 hertz. And here we have our replacement tantalum. We can see that it's 34 microfarads. 1 ohm, so less ESR. It's not super low, but that's not necessarily a bad thing or surprising for tantalums. Very low dissipation factor and a very high Q, almost 38. So the quality of this capacitor is vastly superior to the one we're replacing, which is of course what we want. All right, I'll just show you how I bend the legs. First of all, I'm going to put the little dot which marks the plus side straight up so I can always see it. And it's not necessary, you know, you can hide it if you want, so long as you put it in correctly. That's the most important thing, but I just like to see all the markings. So we've got a marking here on this side and also on this side. So placing the capacitor like so will allow me to, in the future, see all of the markings on that capacitor. And so what I do is I just take some needle nose pliers and I just eye it about where the lead will go into the hole. And then with the dot straight up, I'll just bend the lead straight down. And then with the capacitor's bent lead in the hole, then I can more accurately determine where to pinch this end to bend this one. And we can go ahead and apply some solder on the top. That's perfectly fine. We can then apply the solder to the bottom. Then snip off our leads. Alright, here's our last capacitor, C5. This technique is really what I would suggest that you do for all 3 capacitors based upon the problems that I had with C20. Even if you have the right equipment like I do, it can be really hell to get out the square-shaped plus side because, again, this is a multi-layer board. So what I'm going to do here is just clip off this stock capacitor and leave the legs so that I can solder the new capacitor onto those existing legs. Okay, so we'll just, where you clip him off is really kind of up to you, but obviously away from the body, since the new capacitor is fairly wide. And here's our replacement with the little circular indentation coming straight up, and that way you can see the markings. You can see that just a few millimeters on each side is all of the leg lead that you need. So you could cut off more and then bend it over at an angle. That means you would need to solder more, but it's really up to you how much you want to cut off. And here's with the replacement leads cut. I decided to lengthen this one and bend it down. And this one over here isn't quite bent over and touching the pad. I haven't soldered it yet, just wanted to show you how I have the leads set up. And to make this job easier, I'm going to first apply some solder on the existing leads. And the connections don't look bad at all. Ta-da! There we are, fully recapped with tantalum capacitors. Not bad. Before testing our motherboard, I want to recap and fix the caps lock key on this keyboard. To open the keyboard, you need to remove 5 Phillips head plus screws. I didn't want to bore you with that, so I've already removed them. And with the screws removed, we can just pull off the top plastic. So you can see over here on the left, we've got the controller chip. We've also got another chip over here. And we have our one electrolytic axial capacitor. There is one thing to note about this keyboard, which perhaps could have contributed to the caps lock key having problems, is it's very clear that someone spilled coffee all over this keyboard many years ago, and there's still the residuals of that all over the place. This capacitor will be very easy to desolder because the copper is only on the back side of the board. There's no copper here on the top side of the board where it connects. Before we begin that, I should mention that I needed to repair this chip because there was coffee in the original socket, and I actually removed that socket, and I found I needed to replace the socket, so I replaced that, and in the process one of the legs over here cracked off. You can buy replacements at Mauser, but I decided to take a little X-Acto knife and cut out the nub that was left and resolder back on the leg and put it into this new socket here and then solder it back in. So it is repairable even if you break a leg off an IC, but it really is best if you can replace it to ensure the integrity of the legs. So here's the bottom side of the keyboard. The controller IC I just showed you is here, and the capacitor solder pads are here and here. It's not necessary to add flux, but since I have some, I'll go ahead and put a little dab on each. And we see our capacitor that we just removed is 1113 nanofarads, which is right about 1 microfarad, and 22 ohms for the ESR at 120 hertz. Dissipation factor is fairly low. Q is 53.8. And here's our replacement tantalum. Don't be surprised at the small size. This is actually a 1 microfarad 50 volt rated capacitor. Doesn't need to be 50 volts. We're not going to see 50 volts on this keyboard, but if you get one with a higher voltage rating, you'll get a lower ESR. We see the ESR is only about 10 ohms, so less than half of what the stock capacitor was. 1 microfarad capacitors, you know, the ESR is fairly high anyway, so don't be too surprised at seeing 10 ohms here. Dissipation factor is extremely low. Q is extremely high, 130. I'll just clean off some of the excess flux before putting in our new capacitor. And here he is, placed just right with the tapered edge on the positive side. Compared to the motherboard, that was a very easy job. By the way, this 74LS123 chip works in combination with this capacitor and this 200 kilo ohm resistor to form a monostable multi-vibrator circuit. It's also called a one-shot because this circuit will receive a variety of pulses from the keys, but it will output a fixed width pulse that varies based upon this capacitance and this resistance. So resistors don't go bad over time unless they're burned, so we don't have to worry about this. This is going to be within its 5% tolerance, 200 kilo ohms. But if your capacitance is way larger than 1 microfarad or much lower, then it will change its output pulse. Now obviously there's a timing, safety factor margin there for timing. I'm not sure what that is, but suffice it to say, if you recap, you're going to get a solid capacitance, and with a tantalum even at low temperatures, so you can ensure that this multi-vibrator circuit is producing the correct pulse that the keyboard controller needs to work right. Moving the key is pretty easy. Just have to desolder these two guys. And the holes are nice and big, so it makes it easy to desolder. Here's our caps lock key here. So we basically need to take some needle nose pliers and then pinch to squeeze him. The coffee and cream stains can even be seen on the base of this plastic as well. Folks, don't drink around your keyboards. At this point we can take off a key just by pulling him off like this. Then you'll notice that there are little grooves here, here, and on the other two sides. And you should take an X-Acto knife, razor blade, because you're going to need something very thin to fit it in there and very slightly pull them out. Don't tear them off, but you're just going to try to very carefully insert it in there and then wedge it out. You see that side's done. Then we repeat. And then once you get all four corners loose, you just slide it right out. At this point, I need to take my tweezers to pull off this spring. But as you can see, the spiky point of the spring goes through a little hole in the white plastic piece where the key connects. So I need to pull this little spike out in this direction. Now before proceeding to remove the contents of this switch, it's important to note this little piece of circuit board. There are two indentations here and here. And when you put it back in, you need to make sure those indentations are facing up and out. It is possible to put them face down, which is wrong, because the switch won't work if you do that. It will fit, but it won't work. I've disassembled this before I shot this clip, and I can tell you that it frustrated me to no end until I figured out that these two grooves here have to be facing up towards where the legs, you can see the two pins here, where the legs stick out. We can slide the pins out very easily. And we can see what remains on the inside is that little circuit board piece with the two grooves in it, the white plastic piece, which is here in the middle, and then there's a piece of metal that's here on the side. And here's what that key holder looks like and how it's connected to that little circuit board through this little metal, looks like a staple. The staple, if you remove it, it comes out very easily, but you have to put it in only one way because the length of this staple end is not quite the same as the length of this staple end. But I determined that this is actually not the source of the problem for this key. I also determined that this little metal piece here is also not the source of the problem, so if you have a problem similar to mine, you can just leave that in there. The source of the problem was this guy here. He has the pins connected to this metal plate, and then there's these two little knobs here that are molded to hold the metal piece to the underlying plastic piece. And then on the other side, it looks like this, and then the contact is made by being pushed down. This little, there's an indentation here that you see here, and that makes contact with the metal below. So the problem is that these legs were not coming out enough, and bending the metal did not fix the problem. So what I needed to do was lift up these two little legs a bit more, and I needed an insulator to do that, so I used stickers, actually, labels that go into a laser printer, and I cut really tiny strips, but one wasn't enough because they're paper thin. So I had to use about 5 of them stacked in order to get it to come up enough to where there's enough pressure to be applied on these two legs when the key is pushed down, such that it will make contact. I'll show you how it works with my meter connected. When I push down and it makes contact, my meter will beep. And I need to put my fingers here to keep the contents from popping out, but when I push the switch, you can hear the click and you can see the feet, how they move, those two movable feet. Push it again and it pops out. And without my little stickers there, it would not do that. So the stickers move those little feet more towards that little indented circuit board thing. And I guess it just wore out over time. Great. And of course, because there's so much evidence that coffee was spilled on this keyboard, it's best if I remove all of the keys and then do a thorough cleaning, but that's really beyond the scope of this video. I know that this keyboard worked before. It was only this key that did not work. So what I'm going to do is now test the motherboard with this keyboard to make sure that the caps lock key is working again. Of course, the motherboard is working fine, and making sure that none of my fixes to this chip or the soldering here had caused any problems. Let's now give our fully recapped motherboard and keyboard the smoke test. That's a good sign. And we got a screen. So that's showing you our motherboard is okay, but we'll go ahead and boot from an actual floppy here, because the floppy drive will use the 12 volts. And it booted right to the desktop. So now what we'll do is open up keycaps, which will allow us to test the keyboard and verify the functionality of the caps lock key that I repaired. So with the keycaps program, it will show you whatever keys I'm actually typing on the keyboard. For right now, I'm typing the shift key, and you can see that. I'm going to push down the caps lock key and see if it works. And it does, and to prove it, we'll type something. And there we go. Now, of course, we can erase this and then take off the caps lock key. Yes, it goes off. And it types fine. So this is showing that my repair of the caps lock key works great. And that's it. Be sure to click Show More below this video on YouTube below to expand out the text description that I've written for you, because it contains various links, including the Mauser cart which includes all the capacitors for the motherboard and the keyboard for your Macintosh 128k through the 512ke. If you have a Macintosh Plus, I've put a separate Mauser cart for you there. And the Mauser cart for the Macintosh Plus, it's basically the same capacitors, and the techniques are what you saw in this video. It's just you have more axial capacitors on the Mac Plus. And for that reason, I would suggest that you clip off the stock capacitors and just solder onto the existing legs, because it's much faster and easier for you. Even if you have experience, you saw how much effort it took for some of those capacitors to fully desolder them. If you like this video and were otherwise helped by it, I'd certainly appreciate your click on the thumbs up button. If you're not already subscribed, please subscribe. If you'd like to monetarily support this channel and further the content creation efforts, there's also a PayPal link in the text description below. I wish to thank each and every one of you for watching. Have a wonderful day.